All right, my friends, welcome back. This is day 11. We are working our way through 6.2. This is, in fact, one of my favorite lessons, favorite thing to teach, because you guys always ask, when am I going to use this in the real world? And this is the good stuff that you're going to use in the real world. And if we were in class, we do a ton more examples on buying a house and buying a car and all of that good stuff, but we're going to summarize it for you guys now. So we are used to our regular growth formula. I'm going to write that up at the top. Okay, that's exponential growth. So that's when you've got, that's when you've got a growth rate and a number of years, and that's awesome. But now, typically when we talk about money, you guys are probably old enough to know that when you put money in a bank account, it earns interest. So forever, how much money you put in there, you earn a percentage of that back. And so we're going to talk about what happens when you compound that interest. And so it kind of brings us to a different formula that's a little more complex than just the general exponential growth formula, because that growth rate is being compounded. So our new formula that we're going to start to get familiar with kind of looks like what we ended up with at the end of the last example. So instead of saying Y, we say A, but it's the same thing. It means final amount. Instead of saying A for the initial value, we say P, because we're going to call that the principal value now. We're upping our vocabulary. Instead of writing B, we're going to actually write out that growth rate. So it's going to be 1 plus or minus the rate. And so now the only thing that's really new is this N value, which we kind of touched on in the first example. That one was just finding a monthly growth rate. It wasn't being compounded monthly, but it really is a good segue bringing us into this example. So this time we're going to divide the R by N, and we are going to multiply the time by N. So as you can see, it pretty much all means the same thing. We just use different letters now. So A stands for the final amount, the same way that Y always did. P is our principal amount. So not principal like principal of a school, but principal meaning like initial or starting value. I don't know why they switched up the letters. I didn't make the rules, but alas, here we are. The R stands for rate. And as always, we know that rate is going to be in the form of a decimal. And then the N, I'm going to do at the end. T is time. And then lastly, N stands for number of times interest is compounded. Okay, so this is our equation for compound interest. So the good news is you guys know what to do with like 90% of this equation. Okay, so if we look at our question, it says Tamara invests $5,000 in an account that pays 4% annual interest. How much money will there be in the account after 3 years if the interest is compounded annually or semi-annually or quarterly or monthly? Which means we're going to do 4 individual equations to figure out what that value would be. So we're going to set up the equation like we normally would. Let's do this pink. So we don't know what that final amount is, so we're going to call it A. We know that she starts off with $5,000 in the account. The account pays her for 4%. It doesn't take 4%, so we know that that's an increase in money. It's paying money, so we know that's going to be plus. 4% as a decimal, you can go 4, and you can go 1, 2, or you can do 4 divided by 100. Either way, you're going to get 0.04. Oops, not done yet. Divided by the number of times the interest is compounded annually. I forgot to write that at the bottom. Annually. Ooh. I don't even know what. There we go. Sorry, guys. The number of times that the interest is compounded annually, I'm going to leave that for now. And then whatever that number is, we're going to multiply by the number of years, which is 3. So initial value, growth rate as a percentage, we changed it to a decimal, and the time. Okay, so we're going to make a little chart that helps us remember our n values, and we kind of talked about this in the last example as well. So we know that n per year. So if something happens annually, how many times per year does that happen? Your birthday is annual. Christmas is annual. How many times does something happen per year if it's annual? I really like teaching this lesson in class because you guys say crazy things like 4, 15, or I ask like, how many weeks are there in a year? And you guys go like 57, and it's always a really fun time. So just know that I'm missing you guys a lot right now. Annual happens one time a year. So if the interest is compounded annually, then it's compounded once. If the interest is compounded semi-annually, that means that it happens twice. So if the interest is compounded semi-annually, it's compounded twice in a year. If something is compounded quarterly, that happens 4 times a year. If something happens monthly, that happens 12 times a year. We don't need this for this question, but I'm going to keep going. If something happened weekly, that would happen 52 times a year. And if something happened daily, that would happen 365 times per year. So what we're going to do is we're going to go through this equation and we're going to plug in different values of n. So what happens if the interest is compounded annually? Well, n is 1, so I plug 1 in, and then I throw that all in my calculator. So I'll do it once for you guys, and then otherwise I already have them calculated, so I'm not going to go to my calculator for all of them. But I'll show you one time. So I'm literally going to type it in exactly the way it looks, 5,000, parentheses, 1 plus. I'm going to go ahead and use that alpha y equals so it looks exactly like what I've got written on my paper. Divided by 1. Of course, you're thinking like dividing by 1, multiplying by 1. That doesn't even matter. You're right. We don't need to, but I'm just showing you what you would do with different n values. I'm going to use the caret button above the division button to give me that exponent. Be really careful on this calculator view because it really doesn't look too different. It only raises it up a little bit, but I'm going to multiply n times the number of years. And I hit enter. So that means that if the interest was compounded annually, then that means I put $5,000 in the account. I do absolutely nothing to it. I don't put more money in. I don't look at it. When I come back in 3 years, now I've got $5,624.32 in the account. $5,624.32 in the account. So now let's find out if the interest is compounded semi-annually, if I get more or less money, quarterly more or less money, and then monthly more or less money. So again, I showed you how to do it in the calculator once. I'm just going to use the calculations I've already done. So 5,000 is still the initial, 4% is still the interest, but now if it's compounded semi-annually, that means n is 2. Semi-annually happens 2 times per year. So I run that through on my calculator and I get $5,630.81. So now I'm going to check out quarterly and monthly. We don't have to do daily and weekly. I just made those ones up for you guys. So to do quarterly, I've got $5,000, 1 plus 0.04 divided by n. N is now going to be 4 because quarterly happens 4 times a year. And I just run that through on my calculator and I get $5,634.13. And then I've got one more. I start with $5,000. I've got a 4% interest. And now this is monthly. So monthly means that n is going to be 12 because this happens 12 times a year times 3 years. And that is going to give me $5,634 $636.36. So that's how much will be in the account if it's compounded annually, semi-annually, quarterly, or monthly. So what we're learning is that the more times the interest is compounded per year, the more money you're going to get. Not that it's a huge significant amount, but imagine if you had more money in the account, right? $5,000 it is a lot of money, but not in the grand scheme of life. And so, that's earning about the difference between $625 and $636. But again, money's money and we all want the most of it. I don't think anyone's going to be like, no, I'm good. Give me, 11 less dollars. But imagine, if you had your retirement or something set up and you had a good hundreds of thousands of dollars in there, think about the difference between compounded annually and monthly in terms of how much additional money you could make per year. So yeah, you guys are going to go ahead and try that on your own. Remember, this is your p-value now. Your percentage, always convert it to a decimal, otherwise your answers will be wrong. And then years is time, and then use this good little n-value table over here to help you out with different intervals of compounding. All right. So yeah, I hope that helps. Again, email me, Remind, Google Classroom, every way you know to reach me. And I will be happy to help you with this. Again, I hope you guys are doing well on it. I miss you guys a lot. I hope you're staying safe and healthy. And yeah,